Good day, guys. How are you doing today? So today we continue our lecture series from where we stopped. The earlier lectures, we talked about one of the derived types, which is the array. Now today we are going into the other derived type, which is pointer and string. So what is pointer? And the pointers. A pointer is a variable that stores the memory address of another variable. So it stores the address for every value you have. When you assign a variable into a type, maybe you assign a value to a variable, like maybe 10 equal to int s is equal to 10, then that variable is storing the particular portion of the memory or the RAM, which is the stack. So there is an address, or every location has an address. Even human being where he stays has an address. So if you don't have address, there is no way also to be able to locate it back on the memory. So that is why you say pointer is a variable that stores the memory address of another variable. Once we know the address of a variable, we can easily change the content in that variable. We can easily manipulate any data that is there in that variable. So one of the most powerful and distinguishing feature is on dynamic memory allocations. We have memory allocation, efficient array manipulation, complex data structures like linked lists, trees, and so interacting. If you have taken a course in data structures, then you'll be able to understand what I'm talking about. Talking about linked lists, about trees, interacting directly with the hardware as well. Also talk about memory address. Every variable has a unique memory address in form of hexadecimal number. So I'm going to show us a sample of it as we proceed. So now we can see, as I was saying the other time, a variable contains something, house contains something. The memory address, street address of the house. For example, where you are located, anybody want to locate you, so you are located somewhere. If you are in the school, you have changed address, so you can also be somewhere. If you're not there, someone else also can also occupy. That means the content of that place can also be replaced. So if we use the asterisk sign, so the reference operator and the reference operator to get the address and to point to the memory. You cannot point to the integer ordinarily, so you have to point to the memory. So now how is it declare? This is a variable now. We have int var 10, which is equal to what? Then we declare this 10. Then we now point to this address. We point this to this address. For example, this is the address here now. The address of this is this. In case for you to be able to understand, let's jump in straight to our code to see the demonstration of this. So okay, now we have let's create another folder called like a P8 and then P8 P8, that is pointer just, and let's come here, let's name it as what, how.c. Then we include our std library, the io.h, then int main. So it should be used to this by now. So okay, now let's declare a variable. So we use the reference operator, like int. You can put this asterisk can be here, int s equal to what, 370h, right? This is a pointer, right? It can also be in the middle. Okay, let's demonstrate it so that we can get it. Then we can also get this is this now. But is this thing right? This is not this command should flag an error, which cannot just point to a variable. Or this is a pointer is pointing to this variable. No, it should not be give us the root result. Let me see. This is not working. Why? It's a make pointer from integer without a class. So we have to store the value. We give the value like this. This is stored on the stack in the memory. Then we now have the pointer. Let's create a pointer variable now. A pointer can be PS, we just call it pointer of, it's taking the address of, can also take X, for example. Let's see now. You may see, why do we need this thing? And we need this so that we can the complex part of the hardware, interacting with the hardware. Let's talk to memory. trying to do advanced manipulations. Now let's just firstly print this. Let's print address, and then we have value as well. Value t. If you put a px now, for example, if you say px is this, you have pointing to this, but for you to get the address, you have to use the what? The ampersand, the reference operator. You have that's ps now, and our value ps. Let's try to do this. Can get the value of this. We have issue here. It's saying makes a pointer from integer without a cast. Say without a cast, okay. Just is not giving me it's not the correct something it should be giving me. Now this one should work now. Yeah, I got the address of this. I got the value. I want to get the value of this. Just see. Can see, get the pointer value of this. Sometimes again it can be here as well, or it can be close towards the p like this. So either put the hint here in the middle or this. It still means the same thing. This is the address of this. This is the address on the memory. This is the value of the x. Now you can easily change what is in x now to something. Px equals to maybe 89 without. And you now come again and print the value of x. Let's now print the value of x. You can change the content of a thing without. Let's see. Okay. Just make it a pointer. Can you see? The value of x now is now 89. Imagine we have not changed what is in s. We just go to the memory and change what is inside the variable without what? Without calling x and reassign value to it. Because we know the address of the pointer, we've got the address somewhere. We're able to change what is inside x. You can see I was able to point out what is s because I know the address of s before. So that is, you can see here now. So once you know the address of anything, you should be able to change the content of anything, but then you are able in advanced compilation. You get my point now. You should get my point now. Then let's continue our slides. And you can see you see pointer here pointing to this variable. The point you have this is the one we store the address, is the address of it. The address also store, it can be as a hexadecimal. One thing is that the address also can also change. What you think you have before can also be changed from one another. If you observe from our code, this is 84940. If I compile it back now, what am I saying? What is it coming? Other type of S. Oh, I'm coming. There's an error. I got an error here. Compile it using the normal cd cdp8 g++ -o app.c. Okay, we get it now. We get correct something. So sometimes the wrong command also can fail you. So please just try and run the normal command, to get your result. Can you see now? We are getting what? This is 890, which is different from before. You get here also we got 690 here. Here is 890 here now. You can see that it changes, the address just changes, but the content, it knows, the system know where it allocates that, the variables. Then declaration and initialization. We talk about declaration, we talk about initialization. Sometimes you can also declare without assigning value to it. You can see maybe int pointer. You can just have like int pointer. Later on, you don't assign the value of pointer to the value to something. Understand? So let's see here. Maybe here you can just say same thing here. This declaration. Declaration. The same also with a normal integer value. This is what called initialization. Initialization. So then we store the value of this inside this. If you compile it again, we should get our result. It's a called dumped. Sorry. Called dump PS. Invalid conversion from int to int pointer. Oh, so see, have we issue with my. Okay, let's continue our slide. You'll waste time. So we have data type of the variable. We get it as we go along. We have a sample here. The type of the data will be integer, double, or something else. I said indicate that the pointer name is a pointer. This because anytime you say the asterisk there beside the integer or beside the variable declaration, tell you that it's pointing to something. And so we have the initialization as well. Okay, firstly initialize to null is one maybe to 0 for the first time. Okay, let's firstly initialize it to null to get the value. So equal to null. But if this is in C++, it's not PTL small letter. So then we now have come to our terminal. So get this called dumped. If I put it 0, but cannot point to Shinobi. Why is it not working? It's not working. Okay. Oh, okay. So please, we talk about this. We talk about this memory allocation in future. This and that one. We have memory allocation, malloc. Malloc means memory allocation. Calloc means categorical allocation. Also, we dynamically create arrays of block of variables depending dynamically creating it. So we talk about this so that we get there. So let's continue with what we have here. So the int pointer knows the point to an integer. It is double, also it points to a double. Many binary jack occupies vital for pointer arithmetic and dereferencing. So now this pointer can be used to manage access to share configuration, setting that might be loaded or modify. For instance, our slide is small, so I want to write this slide a little bit. So we can also create a variable here. I will pass in a pointer inside our functions, and also we check it. We run the code, and you can please try the code and check it. Anyone you have issue with, you can let me know in the comment section. Let's see the real world application of it. We also want int logarithm of it. You can also create a pointer. We're going to see a sample of it, creating a pointer even with string characters. So for your level, also to see that. But then we move on along. You see, for complex solving complex problem with it. Can also see pointer to a constant data pointer or data type const PTR cannot be changed through this pointer. The pointer itself can be changed to point to something else. So we see that we point to something else the other time. So when we assign a value to it, so you can see point constant here was not assigned under. You get the address of this value. You have stored the address of this inside this instead of it storing inside there. You have it here before, we point it again to this. Get the which is okay as well. So we have constant types. So these are a sample of it. This can just demonstrate the samples. I make sure that we have like 57 slides here, so that's why I'm watching the slides. So for example, We also have what? Int num, int another something. This is the end of the first statement here. This is the end of another one here. So then standard pointer, we have what? The get address of this and store the value of 15 inside this. So it points to another something. So you can see point to constant. So you can see from the comments. Okay. In a base system, hardware register at a fixed memory location pointers, often volatile and const qualifier are used. Volatile constant on in 32 type. That register is these are just advanced concepts, but you just need to know them. You can go through them. But I will get to them pretty well. Microcontroller programming, one of the courses in the base system design and microprocessor design. We'll be talking about also registers, also in PICMP lab. So now let's cast constant pointer. So we also have a constant. We declare constant. Can you see how status register address is stored? This is the address. Sometimes you can also store the MS, the frequency in a microcontroller development. You can also store it outside this way. You get the frequency in megaohm, in micro. Now, just keep this. Okay, let's see pointer now and how do pointer and array, which is very, very crucial. Pointer and array, how do they interact? How do they relate? How do they communicate together? I think I have a code that demonstrates that. I think I have a code that demonstrates that. Just okay. Just is it this? Yes. I think I have a code here that demonstrates this. Here, for example, now you can see me that I have a constant here. Just copy this and I have a sample code here. Just come and run it. And let's try and run this. Let's see what's going on here. Okay, we have error already. So in our code, so we have, let's take them one by one. So we created a function called a code. This one is a pointer to pointer because string is already a pointer by itself on its own self. For example, you can just do this. I'm coming. Just now, if for example we have a character. If we have a character of, for example, you can just store maybe a character name of a person, right? You can just say, okay, you can say this. You can easily print it out, right? Print F. You can print the character out. Okay, let's print the character out. Let's print the character of this out on its own self. Let's print the character here out now because a string is a what? Combination of characters. You can also what? You can also calculate the string. Let's see the length. If you also want to calculate the length of this string, we can easily calculate it. Okay, size of will be maybe name and divide by what? Size of this of name with the first index. Then we can easily say for int I equal to 0, I less than that is length. So we have I plus. Then we now let's get each of the character array, specifying the name. Let's just get what by index 0, index 1, 2, 3 by in character forms. So now let's just have it this way. Let's now loop over it and print F. Just print the character for me separated by comma. That is %C means character, display character, and there we have name of I. Start from index 0. So we can let me just print a new line here so that we have everything, other ones in the new line. So if we compile this program, yes, can you see I also here? At the end of each string, that's also called what? Non-terminating character here, which is called what? /0, which is not terminator, which is this. That's what you are seeing here, not terminator. You can see it here showing. So that was you're able to identify them after the other. What if we now have like just this name here, like this name here? We just have this. I just have this. I just have these names. Now, can we also find the size of this array? Listen, let's even if you have a string, some character, you go to cast a space, assuming you have a space, then you can easily loop it. Maybe for int I, as the size of int names, the size of name. The first, it can be any index, can be /0, there can be anyone you pick from the index. But then you see some things here, you see some funny things here. So the way string are very manipulated, the way you can manipulate string in other programming language, you cannot do that in C programming language. So okay. That is, then we'll print. Let's try to print the string out. Separate with comma. Names of I. Let's see, we have print f. See, we have an error here. It's not showing me the error, the kind of error we are having here. So, but if we also now remove this, sort of you remove the const, remove this. Let me see the array pointing to array. We are having what? It's not giving the correct bugging. Yeah, because array is this one is also a pointer on its own, a string of characters. Array of string is also a pointer on its own self. So we have to be what? This one has to be what? It be a pointer of characters. Understand? Because this one is also is a character, it's a pointer on its own. So it's a pointer, but then we now have a function that is pointing to this pointer pointing to a pointer. So that, but it can only be done for a string alone. Unlike this integer, we have int here, which is what can only point to what numbers alone, right? Now for this one, I told you, you make it static so that even after this, the content will still be remain after the scope of the function is the escape the function of the functions, so can still retain the value of that. Can still retain the value. Now let's so get the values of these, get the values of that. So for example, just comment this, print x of name. Oh, I'm right. I was calling this. I was calling this. Let me comment it out. Okay, it's not the one. Yeah, just names of the first index are. We got to upgrade new thing here for the first one. Then if we comment it out now, comment it out, and this is name. Okay, we use names here, so we should be able to get it now. Can you see? We get the name because I was wrong. I was picking this first array here, names. It's with names, not name here. So we get the size. Now we're able to loop all through the what item. We're able to get through the what last. Then we can easily also do the same also for numbers as well. To return out, we did it for ordinary days. Let's also return the value of this. Let's call the username here, the function name here. Where is it? Where is it? Okay, here is it. No, it's returning array. We return an array, and we're told we can only return array through either through pointers and structures. Understand? Then we are returning this array now. Let's try to do it for this as well. Let me add another one here. Maybe IBK. Okay. What is going? Okay. So I think yeah, fine. So we should have it now. So username is what car. He said, yeah, we'll get error. It's an error. Just failed to determine the size of names. To determine the size of names. Where am I? Yes, because this is a pointer, a constant, I think, yeah. It's what is it? It said, just static, that for static again. Oh, okay, soon. Oh, don't do for static. Yes. Of numbers, names. This is names. Number is only for one. It's pointer to integer, not pointer to a pointer to integer, not pointer to pointer. Because string is a pointer, array is a pointer to pointer. So that's why we have double asterisk here. So you see a issue here. Size of names. Okay, you want to tell me the size of names. Okay, we have 5 names, for example. Let's just say 5. Size of names. I was sure. Let me check the sample code I wrote here before. Less than 4. It should be fine. Oh, sorry. 8. So, okay, let's try size of names. Okay, let's troubleshoot it. Let's get the first one. Do we get the first one here? It said derived name calling derived. Where am I? Okay, here. Oh, sorry, I'm having double. How can you be compiling? Do we have this sample here? Let me just remove some confusion note here. So we have this. Okay, our names. Okay. Oh. is we still have seen. Okay, this cannot point to a point. This don't point to a point. This is just ordinary a character string. So remove this error. This error. Just remove this. Just comment it out. While you are running, so okay, yeah, okay, it printed it out here. So this function is giving us problem, so I have to comment it out. So now let me try to just uncomment this all names. You also have what? New T 1, 2, 3, 4. That is 4. The other one is not. That is not. So our index should 1, 2, 3, 4, not up to 5. So that means it should be 4. We should be able to get our size of now. That is all names. Now size of all names of index 0. Then self. Okay, it's pointing to only one of it. I can also say, okay, let me just in string. You can also say all names dot size. It's not showing all names dot 5 or 5 elements here. 4, sorry, it's 4. So that is the sample code of it. I can iterate over through the element there. So you can take the type string and characters array. You can also use the string library here in case you want to copy one string. You want to copy one string to the other. Maybe you want to copy a string. Maybe for example, you are also having maybe string 1 of array, maybe car of array of maybe you give it the size of 10, and also you give it this anything. So you also have what? Car string str2. You also having the same 10. Then we can also easily copy so we have a string copy. Can you see from destination to the source? Or source to destination. Destination is a what? String 2, and source is string 1. So we copy it here, and you can also print it here now. Print copy string because of %x. We're able to achieve that through the use of string 2. We're able to achieve that through the help of the string library included here. So then you can do that. You say, okay, just leave it. You don't want me to put anything there. You can see also to copy string Newton to that to string 2. You know, we did not give it at anything before. So you can also have some kind of functions that you also use as well. You can also go through this code for integers and loop it as well. You're able to get the values. What you're going to also see here is that you copy from your the source, this is the destination. You copy from string 1 to string 2. There are other functions, so just type a st, you see other functions. You see string compare in case you want to compare this one equal if they are not equal. So string copy, string span, string compare, this string compare to compare two string. So there are many functions of string you can do. You can see here. You can do that on your own personal study. So then go back to our slide. Say we have this now. We have a pointer pointing to this. So pointer and arrays relationships. you can see that array name as a pointer. The name of an array is most expressions decays into a pointer to its first element. So the array first point to the first element. Can you see? If you are let's see this now. Array name as a pointer. The array name, that the name as a pointer, we know we point from a pointer to a pointer. Array name now as a pointer means the name of an array in most expression decays into a pointer to its first element. For it to point to the first element. So why also a string also point to the first element. That is equal to what? If you also call this now in pointer array, just assign this value to this. You're only pointing to what? The array of the first index alone, not the rest. You point this value, which is what? This is equal to what? Pointer of what? The address of this, or what is stored in array of index 0. Point to array. Now pointer point to only the first one below. Pointer arithmetic. Arithmetic or addition subtraction. Pointer is scale by size of this. Pointer plus 1. Point to array of 1. That is, okay, you want to move to the next one. Pointer plus 1. So this 0 alone. Pointer plus 2. Just this one plus 1. Move to the what? Next one. That is address of pointer point plus size of int. Times size of int. Then you also use that in case you are using iterating over iterations. If pointer equal to array, pointer is equal to the first index. Pointer plus 1 is equal to the what? The first index. Pointer plus I equal to what? The array of what? Of I. Then pointer and array accessing elements. You can see you can also access elements based on pointer as well. Access element just the way we access them, other by index values as well. So you got pointer and array example code. You can see here now. So you can see we have an array of this. A pointer number pointing to what? You point to the what? The number 0. Firstly point to what? To the first number here. And to what? Find the size of this. You find the size of this. You can see we have been doing this one often. So you can see, you can go through this one. We've done something related to this. Understand? You can see you want to get the address, you use /p as a placeholder where to insert the value. So can you see it's highly efficient for transferring processing contiguously. Data block like sensor reading or audio samples stored in an array. You can see the pointer array reward data buffers. So you can also see this as well. I think I've spent much time, that's why I'm rushing the tutorial. It's apology for that. You can also have you can see just the same thing. We create a function to find the maximum, this at the buffer stack. Then function to find the maximum value using pointer arithmetic. It can't. So if buffer starts, understand, equal to null or count is less than equal to 0, return -1. So we are under that kind of exception. Constant if pointer is called the buffer start. So pointer to the current, it point to the what? The current element. Maximum value is the what? You can also do this thing without using a pointer at all. But you also are doing it what? With the use of pointer. So point elements are also, we also have initialized the maximum with the first element. We will now compare, loop over again, which one is now greater compared to the first element you first see, because the first element is greater than what? 0. That will be the maximum number. So now the next element we now compare with what he has stored before. Then if that one is greater, then we store that one as what? As the greater value, on. So now we also have we pass argue function pointer as argument, pass by references, can also pass by argument to functions or pass by reference as well. You can see. You can also swap through integer variables. For example, we have int s and 10, because you can swap the two of them together using pointer. You swap by references, you can also swap by what? By value. So depending. So it's very, very easy. You can see that I replace the content of the first one. I replace in the initial code, then I change the content of one thing, I change to the other. Sometimes you can also create a temporary variable in case you are using normal way, not with pointer at all. So I also to be able to brought your notice here. You can do something in a simple way, small prefer than also doing in a complex way, except the requirement state that because of some reason we have to use this approach. So that's the reason why we have to do it in that way. You can see, you can also point, you can also read the slide, you can read all of them. Pointer to functions, reductions, you can also see pointer to functions. You also have int just taking this, just return A and B to this function, taking function to function, taking a function pointer. Understand? You can also take a function pointer here. Can you just see it's different from the way you declare your variables here? Just create a port. This is what a function is taking in what two parameter here itself. Two parameter. Use a pointer function as an argument. Understand? So then we as an if operation equal to null, return 0 or return operation s and y. So this operation is declared somewhere. Can also see when you are going like sorting. So we are not done data structures. So this may be look weird to you, but just keep in mind you can also refer to it later as well. So compare, just keep on, just lay your hand on the code there and run the code. So you should be able to run all this code. I also want to be running all these codes, but we have like almost 2 hours with this video. I don't want that at all. So we also have the code as well. Also have listing, so character array and C string representation. String are not built in fundamental type. In other programming like Java, C#, Python, we have string as normal something. We use char. We represent them in the form of char, as we have demonstrated the other time. So we also have a C string is a sequence of character terminated by what? A special non-character, as I also told you in the initial stage. Can you see hi? If I say I like this, I will still add this to the end of that high to tell you that there is a non-terminating string character. This no. The array needs a space for h, I, and non-terminator size equal to 3. So it will make it 3. If you find the length of this, you are going to get 3 because this one will be automatically included. It will be automatically included. But you can also use string length to calculate that. So you can also use string length to calculate that. So you get 2 because that one will eliminate that. So you can also get this now. You can see. You can see now. Can you see? Check of this. There's no termination string along in it. So you can also do greetings, names. You can see greeting hello. Assign value to it. In case you don't give it a value here as a string, it automatically calculates it by itself and it's big except, but you cannot create this one then as empty. With either you want your name to be empty without assigning value, then you have to give what a size. Which size can it take or can it hold? So that is what. So we also look at important buffer size. Always ensure character arrays are large enough to hold the string content plus the non-terminator string, which is the word /0. That is in C programming language. String. So the main function itself receive command line argument as an array of C string. Agree. So you can also see this code as well. You can also see because we've done something like this in our initial program. So we're able to what? Pass in a list of arguments from the terminal. This one counts the number of what in the argument, including the file name, as if you still remember that. So we have string library string.h. I once talked about it the other time. So string t, string length, I could calculate excluding this. So in the library has excluded the what? The /0. You can also see provide function for C string length, this string copy, and so on and so forth. Since the destination copies, I see. You can demonstrate the string library as I told you the earlier time. So you can see here now, we have string 1, you can ensure enough space is given for the concatenation. So, but here we don't give the word enough space. They will give 50 here, but here we don't want you have to give a value as well. So you can calculate it. String copy this one to this. You copy this one to this string 4. So copy the content to the string 4. Start string library. Okay. You can use CSV, your personal and daily endeavor. Maybe in case you want to run, you are integrating C into Python, maybe you for performance and efficiency. You can also write C inside Python. So I see some conversion to even read something. I want to use C library to read this code from the what? From the CSV. So you can also do that as well. Also use Python to read it as well. So, and the CSV, don't want to bother you too much on that one. So for test preprocessing and okay, can you see understanding the memory implications indirect for pointers? Be vigilant about pointer initialization, nor the non-pointer, the non-pointer. By being careful, by the time we get to memory, we then talk about the calloc, as I said, the malloc, and the free as well, and how categorical category allocation is done. How the malloc as well, memory allocation is done. So in conclusion, a solid graph of this derived fundamental to mastering C programming. See, you learn this by understanding, especially the syntax. All this we have in the code here. You can see, you can copy, you can do this, you can do that. So you can manipulate the string based on this. But also in C++, instead of this C string, you can just include what? You just see what? C string. You can also see C string. This is a sample of C++ code. You can see a C string to be able to do that as well. So then you come back to our C program alone. So again. So that is it. So please, I know there'll be a lot of challenge for you here with this tutorial. It's because you have any challenge, please let me know. Maybe I will demonstrate a sample project on that you want us to do on string, maybe, and send it to you. Thank you very much. Please like, subscribe. Have a wonderful day. Bye-bye.